Friends, welcome to the class. Today we'll discuss some questions on arithmetic progression. The first question states, for what value of k will k plus 9, 2k minus plus 2k minus 1, 2k plus 7 are consecutive terms of AP? So given terms are k plus 9, 2k minus 1, 2k plus 7. Let the given terms are in AP. If the terms say t1, t2, t3 are in AP, that is arithmetic progression, then we can write t2 minus t1 equals to t3 minus t2. So in this case we can write it is 2k minus 1 minus k plus 9 equals to 2k plus 7 minus 2k minus 1, or on opening the bracket it is 2k minus 1 minus k minus 9 equals to 2k plus 7 minus 2k plus 1, or this implies k minus 10 equals to 8. And so on simplifying left hand side and right hand side, we get k minus 10 equals to 8 or k equals to 18. Now k plus 9 is 18 plus 9, which is 27, and 2k minus 1 is 2 into 18 minus 1, which is 35, and 2k plus 7 is 2 into 18 plus 7, 43. So it is clear 27, 35 and 43 are in AP. That means the required value of k is 18 is the answer. The next question is, if nth term of an AP is 2n plus 1, then find the sum of its first three terms. Given that the nth term of an AP is 2n plus 1, that means we can write an equals to 2n plus 1. So the first term a1 is 2 into 1 plus 1, which is 3, a2 is 2 into 2 plus 1, 5, and a3 equals to 2 into 3 plus 1, which is equals to 7. So the first three terms are 3, 5, and 7. Now their sum equals to 3 plus 5 plus 7, which is equals to 15. Hence the required result is 50. The next question is, how many terms of an AP 18, 16, 14 continuous should be taken so that their sum is 0? So given numbers of AP series is 18, 16, 14 and so on. Here the first term is 18 and the common difference is 16 minus 18, which equals to minus 2. Now we know that the sum of nth term of an AP is given by Sn equals to n by 2 whole into 2a plus n minus 1 whole into d. But here sum is equals to 0. So here Sn can be written as 18 by 2 whole into 2 into 18 plus n minus 1 whole into minus 2. Now as per the given question, Sn equals to 0, that means 18 by 2 whole into 2 into 18 plus n minus 1 whole into minus 2 equals to 0. Or on simplifying we get 9 into 36 minus 2n plus 2 equals to 0, or this implies 2n minus 38 equals to 0. It means n 2n equals to 38 or n equals to 19. Thus the required number of terms to be taken to get the sum to be 0 is 19 is the answer. The next question states, which term of AP 120, 116, 112 continuous is the first negative term? So the first term, second term, third term is given, but which term is the first negative term, that we need to find out. So the given AP series is 120, 116 and 112 and so on. So here the first term a equals to 120 and the common difference is 116 minus 120, which is equals to minus 4. Let the nth term of the AP, an, is the first negative. Now that means an less than equals to 0. We know the nth term of an AP is denoted by an equals to a plus n minus 1 whole into d. So we can write a plus n minus 1 whole into d less than equals to 0, or putting the values of a and d, we can write 120 plus n minus 1 whole into minus 4 less than 0, or 124 minus 4n less than 0, or this implies 124 less than 4n, that means 31 less than n. So the least value, since n greater than 31, the least value of n is 32. That means we can say the 32nd term of the given AP series is the first negative term is the answer. The next question states, the fourth term of an AP is 0. Prove that 25th term of the AP is 3 times its 11th term. Let A is the first term and D is the common difference of the given AP series. We know that the nth term of an AP is given by an equals to a plus n minus 1 whole into d, given that a4 equals to 0, because already it is given fourth term is 0. That means a plus 4 minus 1 whole into d equals to 0, or a plus 3d equals to 0. Or you can write it as a equals to minus 3d. Let this is first equation. Now a11 is a plus 11 minus 1 whole into d, or it is a plus 10d, or it is minus 3d plus 10d, which is equals to 7d, because a is minus 3d, which is obtained from the equation 1. So now we got a11 equals to 7d. Let this is second equation. Now a25 is a plus 25 minus 1 whole into d, or it is a plus 24d, or putting the values of a, it is minus 3 plus 24d, which is equals to 21d, or it can be written as 3 into 7d. But what is 7d? 7d is a11. That means a25 is 3 times of a11. Hence proved. The next question is, the fourth term of an AP is 11. The sum of the fifth and seventh term of an AP is 24. Find the common difference. That A is the first term and D is the common difference of the AP series. We know that the nth term of an AP is given by n equals to a plus n minus 1 whole into d. So the fourth term can be written as a4 equals to a plus 4 minus 1 whole into d, or it is a plus 3d. The fifth term can be written as a5 equals to a plus 5 minus 1 whole into d, or it is a plus 4d. And the seventh term can be written as a plus 7 minus 1 whole into d is equals to a plus 6d. Now, according to the question, a plus 3d equals to 11, because it is already given the fourth term is 11. So a plus 3d equals to 11. Let this is first equation. And a5 plus a7 equals to 24. That means a plus 4d plus a plus 6d equals to 24, or on simplifying we get 2a plus 10d equals to 24, or a plus 5d equals to 12. Let this is second equation. Now, equation 1 implies a plus 3d equals to 11, and minus 1 into equation 2 is minus a minus 5d equals to minus 12. So on adding these two, we get minus d equals to minus 1 by 2, or d equals to 1 by 2. Hence, the common difference is 1 by 2. Find the sum of all three-digit natural numbers which are multiple of 11. So all the three-digit natural numbers which are multiple of 11 are 110, 110, 121, 132, and continues up to 990. That means here the common difference is 121 minus 110, or it is equals to 132 minus 121, which is equals to 11. So you can write d equals to 11. And the given numbers are in AP series because the first term is 110 and the common difference is 11. Here the last term can be written as L, and here L is 990. We know L equals to AN, or it can be written as a plus n minus 1 whole into d. So we can write it as 990 equals to 110 plus n minus 1 whole into 11. Or on simplifying, we get n minus 1 whole into 11 equals to 880, or n minus 1 equals to 80. Or this implies n equals to 81. That means total number of three-digit natural numbers which are multiple of 11 is 81. Now, sum of the nth term in an AP is given by Sn equals to n by 2 whole into 2a plus n minus 1 whole into d, or it can be written as n by 2 whole into a plus n. So here S81 is equals to 81 by 2 plus 110 plus 990, or it is nothing but 81 by 2 is into 1100. Or it is the result on simplifying, we get S81 equals to 44,550. Hence, the sum of the numbers is 44,550 in the answer. The sum of the first n, 2n and 3n terms of an AP are S1, S2 and S3. Prove that S3 equals to 3 times S2 minus S1. We know that the sum of nth terms in an AP is denoted by Sn equals to n by 2 whole into 2a plus n minus 1 whole into d. So here S1 is nothing but sum of the n terms. So S1 is nothing but Sn, or it is equals to n by 2 whole into 2a plus n minus 1 whole into d. Now S2 equals to S2n, because it is S2 is nothing but sum of the twin terms. So here S2 is equals to 2n by 2 whole into 2a plus 2n minus 1 whole into d, and S3 is sum of the 3n terms. So it is S3n equals to 3n by 2 whole into 2a plus 3n minus 1 whole into d. Now S2 minus S1 equals to 2n by 2 whole into 2a plus 2n minus 1 whole into d minus n by 2 whole into 2a plus n minus 1 whole into d, or on taking n by 2 common, it can be written as n by 2 whole into 2 into 2a plus 2n minus 1 whole into d minus 2a plus n minus 1 whole into d. On simplifying, we get it as n by 2 whole into 2a plus 3n minus 1 into d. Now 3 into S2 minus S1 equals to 3n by 2 whole into 2a plus 3n minus 1 whole into d, but 3n by 2 whole into 2a plus 3n minus 1 d is nothing but S3. That means 3 times S2 minus S1 equals to S3, or we can write S3 equals to 3 times of S3, so S2 minus S1, hence proved. If there are 2n plus 1 terms in an AP, prove that the ratio of the sum of odd terms and sum of even terms is n plus 1 whole divided by n. Let AK denotes the kth term of an AP. So AK equals to A plus k minus 1 whole into d. That means we can write in the first term A1 equals to A plus 1 minus 1 whole into d, or it is equals to A. A2 equals to A plus 2 minus 1 whole into d, or it is A plus d, and so on, or A2n plus 1 equals to A plus 2n plus 1 minus 1 whole into d, or it is A plus 2dn. Now, as per the question, S1 equals to A1 plus A3 plus A5 continues up to A2n plus 1, because what is S1? S1 we have assumed to be the sum of the first odd terms, the sum of the odd terms. So, and S2 equals to A2 plus A4 plus A6 and continues up to A2n. Now, S1 equals to A1 plus A3 plus A5 continues up to A2n plus 1, or S1 can be written as n plus 1 whole divided by 2 whole into A plus A2n plus 1, or this implies it is 2n plus 1 whole divided by 2 A plus 2dn, or on simplifying we get S1 equals to n plus 1 whole into A plus dn. Now S2 equals to A2 plus A4 plus A6 and continues up to A2n, or it is nothing but n by 2 whole into A2 plus A2n, or it is n by 2 whole into A plus d plus A plus 2n minus 1 whole into d, or on simplifying we get it is n into A plus dn. Now the record ratio is S1 by S2, which is nothing but n plus 1 whole into A plus dn whole divided by n into A plus dn. Now in both numerator and denominator, A plus dn can be cancelled. So we are getting it to be n plus 1 whole divided by n. Hence proved. The sum of the 4 consecutive natural numbers in an AP is 32. The ratio of the product of the first and last term to the product of middle two terms is 7:15. Find the numbers. Let the 4 consecutive numbers in an AP are a minus 3d, a minus d, a plus d, and a plus 3d. So as per the given question, a plus a minus 3d plus a minus d plus a plus d plus a plus 3d equals to 32. Or this implies 4a equals to 32, that means a equals to 8. Let this is first equation. Also, it is also given a minus 3d whole into a plus 3d whole divided by a minus d whole into a plus d equals to 7/50. Because the ratio of the first and last term, if the first is a minus 3d, last is a plus 3d, to the product of middle two terms. Middle two terms are a minus d and a plus d is 7/15. So it is, the equation goes like this. Or on doing the product, it is a square minus 9d square whole divided by a square minus d square equals to 7/15, because it is a plus a minus b and a plus b. So it is a square minus b square. On simplifying, we get 15a square minus 135d square equals to 7a square minus 7d square. That means we did the cross multiplication. Or this implies 80 square equals to 128d square, or a square equals to 16d square. But what is a square? A is 8 as obtained from the equation 1. So it is 64 equal to 16d square. Or d square equals to 4, or this implies d equals to plus or minus 2. Now when d equals to minus 2, a minus 3d is 8 plus 6, which is 14. A minus d is 8 plus 2, which is 10. A plus d is 8 minus 2, which is 6. And a plus 3d equals to 8 minus 6 equals to 2. Now when d equals to 2, a minus 3d equals to 8 minus 6, which is 2. A minus d is 8 minus 2, which is 6. A plus d is 8 plus 2, which is 10. And a plus 3d is 8 plus 6, which is 14. That means the number in AP are 2, 6, 10, 14, or 14, 10, 6, 2 is the answer. If pth, qth, and rth terms of an AP are a, b, and c respectively, prove that a minus b whole into r plus b minus c whole into p plus c minus a whole into q equals to 0. So given that pth, qth, and rth terms of an AP are a, b, and c respectively, let the first term of the AP is capital A and the common difference is d. So the pth term can be written as a plus p minus 1 whole into d, because nth term of an AP is denoted by an equals to a plus n minus 1 whole into d. Likewise, the qth term can be written as, that means b equals to a plus q minus 1 whole into d, and rth term, which is c, can be written as a plus r minus 1 whole into d. Now a minus b is a plus p minus 1 whole into d minus a plus q minus 1 whole into d, or opening the bracket, it is a minus pd minus d minus a minus qd plus d, or we are getting it is pd minus qd. Similarly, we have b minus c is nothing but qd minus rd, and c minus a is rd minus pd. Now a minus b whole into r plus b minus c whole into p plus c minus a whole into q is pd minus qd whole into r plus qd minus rd whole into p plus rd minus pd whole into q. Or on opening the bracket, we get it is pdr minus qdr plus qdp minus pdr plus qdr minus pdq, which is nothing but 0. Hence proved. "200 logs are stacked in the following manner: 20 logs in the bottom row, 19 logs in the next row, 18 logs in the row next to it, and so on. Find how many rows are there in are the 200 logs placed, and how many logs are in top row. The number of logs stacked in each row in the manner 20, 19, 18, 17, and so on, which forms an AP series. Here the first term is A, which is 20, and the common difference is 19 minus 1, which is 19 minus 20, which is equal to minus 1. Let the number of rows is n. So Sn is nothing but 200, because total number of logs is 200. Now we know Sn equals to n by 2 whole into 2a plus n minus 1 whole into d. So we can write n by 2 whole into 2 into 20 plus n minus 1 whole into minus 1 equals to 200, or it can be written as n into 41 minus n equals to 400, or it is 41n minus n square minus 400 equals to 0, or on multiplying minus sign, n square minus 41n plus 400 equals to 0. Now doing the middle term factorization, we get n minus 25 whole into n minus 16 equals to 0. That means n equals to 25 over 16. When n equals to 25, an equals to a plus n minus 1 whole into d, or it is nothing but 20 plus 25 minus 1 whole into minus 1. It is 20 minus 24, which is minus 4. That means n equals to 24 cannot be accepted. Let's see. When n equals to 16, we get an equals to a plus n minus 1 whole into d, which is nothing but 20 plus 16 minus 1 whole into minus 1, which is 20 minus 15, which is equals to 5. That means the number of rows is 16 and the logs in the top row is 5. Is the answer. Friends, here we saw a few questions. Many of the questions that we discussed here appeared in previous CBSE board exams. So these questions will be very much helpful from exam point of view, but at the same time, keep on practicing more and more such questions. And in case you come across any difficult question, feel free to share your question with me. It will be a pleasure for me if I can help you out in solving your doubts and solving your question. So this much for today's class. Thank you.